Section 2.6, Families of Functions. Parent functions. A family of functions is a group of functions with a common characteristics. A parent function is the simplest function with these characteristics. Today, what we're going to focus on is the parent function of y equals the absolute value of x. We've already graphed that on the previous section, so we know how to graph that. What we want to do is perform a translation to that parent function. A transformation or translation that slides a graph or figure horizontally, which would be left or right, vertically, which would be up or down, or both without changing the size or shape of the graph or figure. Let's take a look at the next slide. And what we want to do is graph the parent function, which we know is y equals the absolute value of x. And then we want to add something outside of the absolute value and subtract something from the outside of the absolute value and see how the function changes. Our original function y equals the absolute value of x, which is the parent function, is in red. We know we can graph that by 0, 0, 1, 1, 2, 2, 3, 3, and so forth. And we know that the opposite x values are equal to the corresponding y value. So a negative 1, 1, negative 2, 2, negative 3, 3. So what we want to do is determine what happens when I add 3 to my parent function of y equals absolute value of x. And what happens is I get the black value, or the black graph, which would be 1, 4, 2, 5, negative 1, 4, negative 2, 5. In other words, every point from my parent function has been translated or moved vertically up 3 units. In other words, 0, 0 now is 0, 1, 2, 3. 1, 1 is now 1, 1, 2, 3, up would be an addition of 4, and over 2, and 2 we would add 3, 3, 4, 5. Same for the corresponding negative x values and their y. If I take a look at y equals the absolute value of x minus 3, and I graph, I'm going to get 0, negative 3, 1, negative 2, 2, negative 1, and its opposite x values corresponds to the y values. In other words, when I subtract from my absolute value or parent function, then what has to happen is each ordered pair just translates or vertically moves down that number of units. So here, 0, 0 would go down 1, 2, 3. 1, 1 would go down 1, 2, 3. 2, 2 would go down 1, 2, 3. In other words, all I need to do is to know how to graph my parent function and then just move those ordered pairs up 3 if it's a positive number of units, or down by 3 if it's a negative number of units. On our next slide, we have graphed our parent function y equals the absolute value of x in red. And we already know how to do that from the previous section in the previous slide. What we have done is changed inside the absolute value. Here we have x plus 2 inside the absolute value and x minus 2 inside the absolute value. The previous slide we had the change on the outside of the absolute value, and that moved our function up or down. Let's see what happens to our function when we actually have x plus 2 or something changed inside our absolute value. Here I have the values in our table, so that would be 0, 2, negative 1, 1, negative 2, 0, negative 3, 1, and negative 4, 2. So notice what happened to our parent function ordered pairs. When I have something added to my value inside the absolute value, that actually moved our ordered pairs of our parent function to the left that many units. So here it was a plus 2, so our vertex would be over 1, 2 to the left, our value here over 1, 2 to the left, and here over 1, 2 to the left. We go to the right side of my parent function, move that ordered pair 2, 1, 2, and the next one 1, 2. So we wouldn't really have to graph this or generate a table. I would just know that the parent function would then be translated or moved left by that many units if my value inside the absolute value changed. Well, I'm going to assume, and I will check it out, that if this plus 2 moves my function to the left, my value here, when I have a minus sign inside the absolute value, will move my function to the right. Let's verify that by graphing these table of values. So here I have 0, 2, 1, 1, 2, 0, 3, 1, and 4, 2. And I take my parent function, and each ordered pair is translated or moved to the right that many units, and here it would be 2. So 0, 0 would go to 2, 0. Then I'd go to this ordered pair, 1, 2, and that ordered pair, 1, 2. This ordered pair would move 2 units to the right, 1, 2, and so forth. This slide defines the translations to a parent function, and here we're going to use it for the family of absolute value functions. So if we're going to have a vertical translation on the parent function of y equals the absolute value of x, we're going to have k define that vertical translation. And if k is positive or greater than 0, then that's going to tell me that it's going to translate up that many units. If k is less than 0 or negative, it's going to translate down or move down that many units. So our parent function is y equals the absolute value of x. For up and down, absolute value plus k moves up, absolute value minus k moves down. Here, if we have a horizontal translation, which would be left or right, we have our parent function again, which is y equals absolute value of x. Our general function is y equals absolute value of x minus h. If h is greater than 0, it will look like our parent function on our previous slide was absolute value of x minus 2. H is actually a positive 2. And that's why we moved that function to the right 2 units, even though there was a minus sign inside our absolute value. If we have h is less than 0, so h would actually be a negative value, then when I substitute into this general function here, that would give me a negative times a negative. That would give me x plus h inside the absolute value, which means that would actually move my function to the left because the h was negative. So here I have a combined translation where h will determine whether I move left or right. If h is negative, it moves my function to the left, which will represent a positive inside the absolute value. If h is positive, then it will move my function to the right. If k is negative, it will move my function down. If k is positive, it will move up. Let's take a look at an example. Here they want us to graph the equation. They want us to use a translation of the parent function rather than to create a table. Recall that our general formula is y equals the absolute value of x minus h plus k. We have no k for a vertical translation or up or down, so I know it must stay at the same level in height. I have a value of h, and here, since my symbol is a positive inside my absolute value, h must be a negative 4, because a negative times a negative would give me the positive 4. This tells me that my function needs to move to the left 4 units. So I just take every ordered pair from my parent function and move it to the left 4 units. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And this graph is for the function y equals the absolute value of x plus 4. Here they want us to do the same thing, but on the function of y equals the absolute value of x minus 3 plus 2. Recall that our general formula is equal to y equals the absolute value of x minus h plus k. Here k is a positive 2. Therefore, my function will move up 2 units. Here I have a value of 3. H equals 3. And the minus sign stayed, therefore that must be a positive 3. That means that my function will move to the right 3 units. So I'm going to take each ordered pair, move it to the right 3 units, and up 2 units. So I have this ordered pair, 1, 2, 3, up 2. This ordered pair, 1, 2, 3, up 2. This ordered pair, 1, 2, 3, up 2. 1, 2, 3, up 2, and 1, 2, 3, up 2. And that gives me the function y equals the absolute value of x minus 3 plus 2. So as long as I know my parent function, I can generate my translation of the function given to me very quickly. Here they want us to translate y equals x plus 1 minus 3. I don't have my parent function graphed, but I do know that my parent function for y equals absolute value of x is 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. And I know that my general formula is y equals the absolute value of x minus h plus k. Here, k is a negative 3. Therefore, that's going to go down 3 units for each ordered pair. And here I have h equal to a negative 1. I know that because a negative times a negative will give me a positive 1. That means I need to move each ordered pair to the left 1 unit. So I'm going to move each ordered pair to the left 1 unit and down 3 units. So here, over 1, down 1, 2, 3. Over 1, down 1, 2, 3. To the left 1, down 1, 2, 3. To the left 1, down 1, 2, 3. To the left 1, down 1, 2, 3. And this graph represents the function of y equals the absolute value of x plus 1 minus 3. Here, they want us to write the equation to translate the given function 4 units down. Recall that our general formula is y equals the absolute value of x minus h plus k. K represents my vertical translation, or up and down. Here they want 4 units down, therefore y equals the absolute value of 3x, and outside the function, 4 units down would represent a minus 4. Our next example wants us to write the equation to translate the function 2 units up. Recall our parent function y equals the absolute value of x, but we use this general function to use for translations. Y equals the absolute value of x minus h plus k. Here, we know that h would be a negative 1 because a negative times a negative would give us the positive 1. That tells us we're moving the function to the left 1 unit. But we want to translate this unit also 2 units up. That would be for our value of k on the exterior of our absolute value. So to do that, we would write y equals the absolute value of x plus 1. And what we want to do is move this function up 2 units, which means that would be a positive 2. So that would be plus 2. So our new function would be y equals the absolute value of x plus 1 plus 2. The next example, they want us to write the equation to translate the function 3 units to the left. A general function, y equals the absolute value of x minus h plus k. We don't want to move this function up or down, so I don't need to worry about k. And the value for k here would be 0. So what I need to worry about is I want to move this to the left 3 units. Therefore, h has to be a negative 3. And in our general function, if I substitute a negative 3 in for h, that would give me a negative times a negative, which would be a positive. Therefore, in my function, y equals the absolute value of a negative 3x, and h is going to be a negative 3, and our general function has a negative already here. Therefore, when I simplify, y equals the absolute value of a negative 3x plus 3 will give us a translation to the left 3 units. Our next example, they want us to write the equation to translate the function 2 units to the right. Here, our general function, again, is y equals the absolute value of x minus h plus k. They want us to translate this 2 units to the right. Therefore, h is going to be a positive 2. And if I rewrote this to fit this formula, that would give me y equals the absolute value of 2x minus But since this is a plus sign, my h would be a negative 3. Now what I want to do is to have this negative 3, which represents h, have an addition of 2 units to translate it to the right 2 units. So therefore, that would be h, the new h, that is going to be a negative 3 plus 2, which represents a negative 1. So when I create that new function, y equals the absolute value of 2x minus h is a negative 1 for the translation from a negative 3 to a negative 1 of 2 units. Then simplify, y equals the absolute value of 2x plus 1 when I simplify. And that represents the translation of this function 2 units to the right.